Hello, dear friends. The topic of my presentation is Go Enlightenment, 8 insights for the next level. My name is Alexei Komisev. I'm a developer, architect, information security enthusiast, and I've been doing architecture of distributed high-load applications. So over the past 8 years, I've been doing Go development. And for me, Go is the main language, and actually the only one at the moment. Also, I've been doing WebAssembly technology for 6 years. I've been making presentations about that. I have my own projects where the front end for the multi-user application is written fully in Go and can also be implemented in the browser. What I would like to start with, firstly, a couple of words about the topic of our presentation, Go Enlightenment, 8 insights. Maybe you've become curious. It's not out of the blue. I would like to build my presentation in the Oriental style, in Oriental religion and philosophy, the concepts of enlightenment in Buddhism is kind of a process that allows you to go outside the circle of, daily routine. And I would like this presentation to become a way of changing the mindset, changing your attitude toward Go. I love Go. Let me ask the audience, please raise your hands who develop in Go. Oh, great, quite a lot of people. And for whom Go is the main development language. Great, thank you. Well, basically, what would I like to start with? Over the years that I've been doing development, I ran quite a lot of interviews. And during these interviews, my style is like this. I ask questions and try to get to some dialogue with my candidate. And quite often, I encounter the same patterns where people somehow can't ask questions which I believe to be important, or even the main ones. And I think that one of the useful results of this presentation will be that the audience will be passing interviews, or hiring interviews better. So what would I like to start with? The first question, well, maybe not the very first one in interviews, but one of the first ones. It's about Go proverbs. It's like Go. It was Rob Pike who offered this. There are just 3, Rob Pike and Thompson, Robert Greason. And by the way, only Robert Greason remained, and now Rob Pike and Thompson went away from Go. So where does the root grow of this concept of Go proverbs? Rob Pike was researching the game of Go. And by the way, this is the reason why. So it's actually not a coincidence that they called the language Go. He found his book, Go Proverbs Illustrated by Kensaku Sigawa. And even though this person looks just like a regular, a retired senior gentleman, this is a person that has a 9th Dan in Go. It's quite a powerful personality. And he published a book, this book, which speaks by way of proverbs, how to play Go. The game of Go has a certain similarity with the Go language. What is it? It's very easy to start doing it, but very, very difficult to become a real master in the game, because the complexity is humongous. The number of combinations in the classic Go field is incredible. If you take all atoms in the universe and add another several dozen orders of magnitude. That will be the number of combinations. And the story is quite similar with the Go language. On the whole, the specification is not too large. There are not too many entities, but it doesn't mean that it's very easy to develop software in Go, all the more so that Go is about competitiveness. So if you take this book, I liked this algorithm very much. There are times when even a fight over nothing means something.
Иногда бывают такие времена, что даже, казалось бы, борьба бессмысленная, тем не менее обретает какой-то смысл. У нее есть множество интерпретаций. Вот одна...
So there are many interpretations of this. So there are times an adversary is seeing that you start fighting and they can start making mistakes or errors. But going closer to the language, I wrote down all these Go proverbs proposed by Rob Pike, and there's one other added. There's a link at the bottom, so you can use this link to go to this list. I won't be reading all of them, but just the approach evoked my interest. It's a real Oriental approach when we add some aphorism, and it has some deep meaning that you need to unwrap, but at the same time, it sounds very simple. Well, I decided not to go over the most popular ones, because perhaps the most popular one would be don't communicate by sharing memory, share memory by communicating. They usually start to learn the Go language from this. I chose those of them who were forgotten undeservedly. Like the bigger the interface, the weaker the abstraction. In Go, as opposed to Java, the interface quite often has only one method. Everybody knows the read and write interface. It's super friendly, super widespread. But this approach is very different from what other languages have. Don't just check errors, handle them gracefully. Quite often, we just pass the error somewhere, return it, and in fact, we could have tried to process it in a more exciting way. Documentation is for users. I think this is the last one to be mentioned, but what it's all about is that we write code for other people. And quite often we tend to write something. This function takes these arguments as input, returns these values, but in fact you would like to learn more about what is the reason behind this function, why certain decisions have been made when developing it. And on the whole, let me give you another quote from Rob Pike. It's all in the context of Go proverbs. There's a lot of opinions about how to program, how to correctly write the program. And one of the things that Go has done, I think, is create a community around a certain way of programming. So basically, there's no right or wrong. They may all be good enough. It's just that the creators of the language offered a certain approach, a certain philosophy, if will, and the community formed around this philosophy. So probably the people who are present in this room are supporting this philosophy, subscribing to this philosophy, and they agree that this is a more convenient way of writing programs. Another thing that nobody is talking about, I guess there was only one person over all this time who told me how it expands. But then the question stuck. It's CSP, communication process. That's the foundation of the language. That's on what it being built, communicating sequential processes. There's this great person called Tony Hoare. Tony is his preferred name. Basically, he has three official names: Charles, Anthony, and Richard. He also has a knight title, and he was born while the British Empire was still in place in Sri Lanka. And so Tony Hoare can be considered the fourth creator of the language, because without CSP, this language wouldn't have existed. He's still living. He's 91 years old.
такой интересный факт. Учился в
And
МГУ Ломоносова. То есть он
he has a degree with Moscow State University. So he first graduated from Oxford, then he went to serve in the Navy, learned Russian, and then went through the studies in Moscow State University. He was dealing with machine translation. But then, unfortunately, in 61, a crisis happened. The U.S. spy plane U-2 was shot down over U.S. But every biography of his says that his alma maters are Oxford and Lomonosov, Moscow State. So in 1974, he published a paper called Communicating Sequential Processes. So basically, it's the article having nothing to do with CSP as in running today. It was a language called CSP. And a full paper that shows the theory and algebra of the processes dates 1984. A theory of communicating sequential processes was written in the co-authorship between Tony Hoare and also Brooks and Roscoe. Talking about CSP, one needs to mention that there's a whole branch among programming languages, including Limbo, Aleph, and Newsquik. And by the way, Newsquik was also created by Rob Pipe. And before Newsquik, there had been just Squik. And so Go is perhaps the most modern and the most popular language that implements the CSP model, in which the program is presented by a combination of competing processes. Programming is one of the most difficult areas of computer science. So CSP is a complete model that has completeness and proposes a certain approach. That's why we split our async program into a lot of synchronous ones that communicate among another via channels. The processes know channels, but they don't know other processes. Communication is happening synchronously. That's the foundation of CSP. And there's this concept of choice, where depending on which channel the message comes to us, we can choose the execution scenario. And for CSP, it's also important to mention that the competing model, actor model, was proposed even a bit earlier by Carl Hewitt in 1973, and CSP got some inspiration for this model, actually. So there's this language Erlang. It was developed by Ericsson. The creator was Joe Armstrong, Robert Wording, and Mike Williams in 1986. This is also quite a popular language. There are quite a lot of solutions based on Erlang, Redbit, for instance, and it's interesting to compare. And again, I'm quoting Rob Pike, so that I should be blamed that I do the wrong comparison. He says that these models are also good enough, so you could write the actors in CSP and the other way around. He also says, but Go's main things is channels. The whole difference is that in CSP, the processes are anonymous. In the actors model, they have IDs, and the sending is done using these IDs. The analogy is how we work with file. You can use file names and file descriptors. So CSP is just like we use file descriptors to address the files. In CSP, to send messages, you use channel. In the actor model, you send direct. And the main thing, the configuration is CSP is synchronous, and in actor model, async. And there's this thing called mailbox. But again, one can be written via the other. And what's really curious, Erlang is closer to the original version of CSP of 1978, because in that version of CSP, the sending is done direct, however strange it may seem. The third insight is Go spec. I'm asking a question. Does Go have a specification? And quite often people get stuck here.
Не буду как бы
I am not going to
делать паузу, да?
tease you here.
Существует формальный
Go does have a formal specification. It would seem, what's so special about that? Thing is, there are languages that don't have a formal specification, like Rust, for instance. For Rust, there's a book called the Rust programming language, or just the book, as people call it.
собственно, описывает
And with Go, there's a formal specification that describes everything that exists in the language and all the guarantees that the language gives. Again, you have this link at the bottom left corner. So it gives you a certain tool to figure out with complicated things. It also simplifies the development of compilers. So what conclusions can be drawn from this?
я бы делал на самом деле не на основе того, что
I would make conclusions not on what is there in the specification, but what it doesn't include. It has nothing about concurrency model. It has nothing about runtime, scheduler, non-blocking I/O, nothing about heap or stack. There are a lot of discussions in the Go context how to get rid of the specification. No, the specification doesn't have anything about heap and stack. What conclusions can we make? As a minimum, Go, from the formal point of view, offers you no guarantees. All the things that I've listed here are up to implementation. So if, for instance, they're important for us, if we optimize the program, we can't expect this behavior to be maintained in the next version of Go or on a different architecture. This is basically an assumption we're making. And if you take such an important concept as concurrency, which is the foundation of the language, for Go, just CSP, just for Java, it's an object-oriented paradigm. Is just available based on the primitives. So if you take everything, including the word concurrent, so I've written all the places where this word exists. There are very few of them. It's the definition of the language. It's a quote about channels. It's the Go statement.
и про инициализацию пакета.
And Go statement and the packet initialization. Next thing, Go memory model. Over all this time, over all the dozens of interviews, nobody answered, and I was interviewing people at very different levels, from junior to senior. Nobody answered my question. I'm asking, what is Go memory model? I say, they tell me, what's memory model? It's a memory model. I say, what's a memory model? There's heap, stack, allocations. No, it's not about heap or stack. Go memory model is about the guarantees that if one routine has written somewhere, some value somewhere, the other Go routine would see it. So basically, it's a restriction. It's a description of guarantees of description of the synchronous program written in the terms of sync before. There's quite a curious thing in the beginning of the document. I very much like this quote. If you must read the rest of this document to understand the behavior of your program,
Вы пытаетесь,
you're being too clever.
ну или слишком умны.
Don't be clever.
Don't be clever. То есть не надо.
Don't do this.
Говоря, перекликается
And by the way, this fits very well with one of Go proverbs. Clear is better than clear.
чтобы понять, какие
Nevertheless, it's very important to understand this. What real guarantees Go offers. So Go specification of the Go memory model, I think, is a great foundation that will help you a lot in any event. And another thing, this document, as opposed to the specification, keeps being updated. The language is developed. Some generics have been added. The document is updated quite rarely. The latest one was in 2022. Raskops wrote, and this is the quote from the update proposal. And the curious point is that before 2022, Go memory model had nothing about atomic. So from the formal point of view, the atomics were not giving a guarantee of synchronization. Of course, it wasn't exactly like this. It would work, but it wasn't fixed. In theory, so they could make a different decision and everything would start working differently. As an example, take this program.
кто-нибудь предположить,
Maybe, can someone suppose or guess what the result will be, what we'll get at the output?
можно с места.
You can shout from the seat. Blank line?
Именно выведет пустую строку или
It will output blank speed, or will it hang up? What will happen? Yes, indeed, you're right. The right answer is it hasn't been defined. Actually, if you run it on your own machine, you'll probably see it outputting hello world, and you'll think that it's the way it should work. We indeed wait until the that equals true, and we'll see hello world. But even if the Go routine main will see that done equals true, the Go language doesn't give guarantee that it follows from this that A will equal hello world. More than that, Go memory model says that there are no guarantees at all that this cycle will finish. There's no guarantees at all that the second Go routine will see that it's become true. Why? Because there's not a single sync primitive between these two Go routines. So this is indeed undefined behavior, even if in your specific computer, in your specific architecture, hello world will be output. So memory models are a very important thing for understanding such things, especially. Next thing, multitasking model. Examples. Before Go 1.14, and we put Go Mac Pro with a 1 here, starts Go run, and then hung up. Why do we hang up? Because the runtime was not working completely correctly, and starting with Go version 1.14 started to work correctly. Why? Well, basically, the definition of what a multitasking model is goes with the truth of the operating system. Operating systems divide into operational and preemptive ones, and the modern ones are preemption about creation, so when they use interrupts. In the context of runtime schedulers, green threads, this concept is not totally defined, so we're relying on it. So not going too much into detail what model exists before version 1.14, then starting with 1.14, it would be correct to say that it has become fully synchronously preemptive. How does it work? There's a parallel stream responsible, or thread responsible for preemption. I'll be talking in terms of GNP, but unfortunately I don't have the time to expound on that in a lot of detail. So there's an SMON, it's a special thread, and there's a G routine, it takes more than 10 milliseconds, and then SysMon sends a special signal, SIGAG, then the handler of this signal does it work on the thread, and we see whether we're in a safe point or not. If we're not in the safe point, we just skip this iteration and maybe switch at the next phase. And as part of the proposal implementing this model, there was a connected proposal related to save posts everywhere about saving the context for map and stack and everything. So the probability of getting into unsafe point is not very high. In Windows, there are similar primitives, suspend threads, set thread context, similar model. And again, this thing is about implementation. And here we gradually come to the place where this simplicity of the model goes against the catastrophic complexity of how it really works in practice. So we gradually go from theory to practice and see that nothing is as simple as one would think. I've already mentioned SysMon. Let me say another few words. Of course, you can find information about SysMon, even though nobody has ever given me an answer in an interview what's SysMon. NetPolar, it's even worse. So what does SysMon do in addition to what I've said? It runs the timers, it makes NetPolar calls, it starts garbage collector, and it preempts the NetG. NetPolar. We rarely get to this point in interviews, but nevertheless, this is a place with a problem. What we're talking about, the network interaction is quite sophisticated and difficult. It's very hard for the CPU. So therefore, all sorts of async I/O over the network have been invented. What happens inside, under the hood? This is a rough schematic, but let me just explain. Not going too much into detail. I will be relying on Linux because I think everybody knows Linux better than other OSs. First, we have a server that accepts the connection. We have a system called accept that allows us to get a new file from the socket that we've accepted. So we have the EPOL mechanism. First, you need to create an EPOL instance somewhere, and then when we get a descriptor, we nude over ACTL, add this file descriptor, so-called interspace, and then we park our existing Go routine, because this all are non-blocking I/O. All the system calls complete immediately. We park G because we don't know whether it comes or not, and we run the schedule procedure. This schedule procedure launches in a number of scenarios. For instance, when a new M is launched, when G is parked, when G is completed, when runtime call is issued. If you look for information how this procedure is implemented, you foresee that the information is rare and far between. I don't quite understand why it so happened, because maybe there are differences between versions. I don't think there have been any cardinal changes, but nevertheless, I've done a bit of work and took a look at the source code. So the current implementation is Go 1.2. The following thing. First, we start to try to shadow GC. So we failed, and we do global rank 1. Why 161? Because 161 is a prime number, and we get it's neither too big nor too small. It's some intermediate value, so that something could be taken from the global queue, because there's a chance that we'll never get there. Then we look at the local run queue, then we again look in the global run queue, and there's no contradiction here. And then, for the first time, we look into the net polar, whether it has any routines that have something to read. After that, we do spinning. Then we do work stealing of other Ps. If we're at the GC mark stage, we try to implement it as well. And then, after some intermediate steps, we call netpol again. There's some other work to do here. And then at the end of the day, if you haven't found anything, we stop this M. So this is the scheduled procedure, how it looks. You see, there are two calls to netpol as an attempt to find some routines, to understand what to do with this network socket. In even more detail, to see how the interaction with the netpol procedure is happening. So schedule to netpol, then we go to the EPOL wait system call. For EPOL wait, you set a timeout. You can assign it to Unity. Assign Unity to it would be, or 0 as a non-blocking, or Unity as fully blocking. And then you return the data and the operating system. The netpol returns a connected list of unblocked G. Schedule executes the first G, G of 0, the rest G of 1, 2, and -1. All of them are moved to the queue. Apart from scheduling, netpol can be called over different phases of garbage collector. So we are trying to spread it evenly using this fairness concept. So it's clear that these things are quite difficult, quite sophisticated, but nevertheless, in some situations, it's very important that you understand that these things also exist. The runtime is complicated. I sometimes hear, well, there were people who told me in an interview that Go is a simple language. I've learned it completely. I don't know what to learn more. Well, I think there's no bottom here at all. You can go as deep as you wish. Next thing, alternative compilers. And here I would like to proceed to an attempt to go away from the usual model. We're all used to the standard Go compiler. It works very well. It's written perfectly, but it's not the only way to build a Go program. What are the options? GCC Go and Tiny Go. From the outset, GCC Go is a front-end to the well-known GCC compiler. I'm not going to dwell on that a lot for a simple reason. From some point in time, it stopped developing. And in fact, based on the history of commit, it looks like it was written totally by Jens van Stelen, one of the members of the Go work team. And I found this issue. The year 2024, August, the person says, does GCC Go still not suggest support generics? And Jan Lars Taylor says, does not yet support generics. And it's surprising, considering that he's the author of both the front-end and generic implementation in Go. So let's skip, therefore, to Tiny Go immediately. It's an alternative compiler. So what is it talking about? It's an open source project managed by Ike van Latten, who created it, and Ron Evans. There are a lot of other great programmers there. It's sponsored by Google. So Google actually shells out money for this project. So why this code was created? The project was initiated to write controllers so that you can write a program in Arduino. It's not the only application area. It also supported and actively supported in WebAssembly, not only on the browser but also on the backends. And actually, Tiny Go uses its VM, and it can be used to create program for the desktop. So on the microcontroller, a program written in Go looks like this. I mean, written in Go for Tiny Go looks like this. So this program will just let the LED blink. But what's curious here, apart from that, we have a special machine import that is absent from standard libraries, and also it's a VR mapper. So this controller doesn't have an operating system, and the compiler allows us writing hardware to run directly, writing software to run them directly on hardware without an operating system. And this concept is now becoming quite popular. If you take any desktop, I took Windows. We take Hello World, run it, Tiny Go run, we launch it, no problems, and if you take a look at the binary size, it's considerably smaller than the similar binary that would have been compiled by a regular compiler. And it also, it supports Go routines as well. All the functionality is there, even though Tiny Go supports the standard library in its entirety. Well, with certain exceptions. Well, you can't compile protocols, for instance, so you have to bypass. The binaries as such are no different. So had it been Linux, it would have been L. And the last one for today, it's WebAssembly. What is it all about, and why it is of interest to us? Actually, WebAssembly from the outset is some universal bytecode. They started to be used. There's a biased notion that WebAssembly, because it has the word web, has been devised specifically for web browsers. This is not true. Actually, even in the definition in core spec 1.0, it says no specific assumptions are made. It's not fixed on the web. It's done as a description of a visual processor, and the technology as such is a set of instructions of virtual processor. There are 172 of them all told. It's a stack machine, and one can draw analogies with Java, by the way. And the specification, for instance, says that the operand stack does not need to be maintained. It's a very exciting thing. And in addition to the fact that it's an abstraction of modern equipment, modern hardware, what does it do? It allows you, it has this portability. We compile once and then run anywhere in browser servers, IoT devices. It provides for security, which is the biggest focus here. So in order for the module, WebAssembly module, to do something, it needs to be provided either import explicitly, or the model itself should provide export that we can address. We don't need to think about some strange, some sophisticated lock, but we just get away from the problem. So all the module can do is to calculate the mathematics, and this is the foundation of the execution. This said, the bytecode is compiled into native code in most runtime environments. All the possible languages are supported: Go, Rust, C, C++, Java, Python. Only HTML is not, for clear reason. And also, in the past, we used to live in a paradigm where, for instance, you have some good code. It's been written, it runs very well, no problems, and then a new language arrives, a new modern framework. What do? We always rewrite to this new framework or language, even though the code is good. It has been written by programmers who understood what they were doing. SQF, for instance. So why do we do that? WebAssembly allows us just to compile this code and embed it anywhere. I made a presentation as the previous high load on the 24th of December. This is a direct link to this presentation. I dwelt on the technology in quite some detail and its use in high load on our project. This is a direct link. It's not open. If you're interested, so you can just take a picture and take a look. In the Go context and in the WebAssembly context, I think it's important to mention the following project. I think it has been undeservedly forgotten, and let me explain why. Before WebAssembly, there was this story with transpiler. They were very popular, especially from one language to the other, especially. And Go was not an exception. Go was in JavaScript. And this transpiler was amazing. It worked very well. And I'm telling you about my own project where we used it. So before WebAssembly, I used Gopher.js. Gopher.js allowed executing any program in the browser. You could start a game. You can see a lot of videos about that. A community of really great developers took shape around this technology. They wrote a lot of tools. And the two persons that I'd like to mention, because I think they've also been undeservedly forgotten, it's Richard Monsieur, the creator of Gopher.js, and Dmitry Shuralyov. There were other developers. Unfortunately, I won't be able to mention all of them, but these two made the biggest contribution. Dmitry Shuralyov now works in Go13, and he's English, by the way, even though he has a Russian name and surname. Why did I remember them? Because the official support of Go compiler in WebAssembly is based on the proposal and on the work that has been done by Richard and CEO as part of Gopher.js. So I am showing a screenshot here. This is his proposal to add the compilation target to WebAssembly, and it's exactly thanks to the work that done in Gopher.js. This support appeared over a very short span of time, and even though it has a status of experimental, in fact, is prod ready, and you don't even need to study it. I use it in my project. It works perfectly. The only place where the API was broken, its API is Go 1.14, and it's in its history now. So it's a very good. So if you need to write a front end on Go, I strongly recommend you using this library, because you may get confused, and there are some other libraries. They're in different statuses. Some, are better, some worse. I suggest that you don't waste your time. Complete bullshit. Just use this. This library is initially authored by Dominic Homov. is also very well known in the Go community. It's a very good library. There's something missing there, but most things are there. And TinyGo also supports WebAssembly. It can be used in browser and backend, but of course support is a bit less than perfect in terms of libraries. There are also some interesting things that better fit backend. You can take the scheduler out, Go routine will not be supported. There are just simple modules that filter something. You can add them as plugins. The code will be lighter, will run faster. The binary file will be smaller. A lot of people are saying that this is a program in the browser. Don't believe them. Complete bullshit. I tell you, you'll have 10 megabytes and zip will compress it very well. And you won't even know. So you can cache it in the browser for good, and it will run perfectly there. And in fact, talking about the backend support, there's another excellent project, Waziro. It's a runtime, it's an engine for WebAssembly, written completely in Go, and it only uses the standard library. It doesn't have any other dependencies, no third-party libraries apart from the standard library, no CGO, nothing. If you want to build in some logic on WebAssembly into your Go process, it's easy done by Waziro. It has its compiler, or native code compiler for ARM, for x64. It can also do optimization. Okay, no, it's not JIT compilation, but nevertheless, it's quite good. It's also a very good project, and I recommend that you take a look at it. Well, what kind of conclusions can one make of this all? I will not, put out a lot of bullets or recall what I've told. The main idea is, in my personal opinion, Go has quite a deep philosophy. You can understand it whichever way you like. And again, it's not me, the only person that went mad, because the project was built with an analogy with the game of Go. In Go, I do believe there's a certain philosophy, underlying philosophy and approaches, and a community of people who are sharing this approach. And this is how I explain a certain hate, if not hatred, but then lack of love on behalf of developers used other languages. You'll know their names. They don't understand why you have variables of one letter. Why do you have interfaces with one method? Why do you need these channels when you have mutexes, great mutexes? Go has this philosophy. Go has been able to create this community, and it's quite large. This shows this is proven by the whole popularity of the language. I think it's become super popular, but it's not the only thing. So behind this simplicity, there's a lot of complexity that lurks. There are sophisticated engineering solutions. The Go runtime is a super engine that was created by very, very sophisticated people, super people. And there's a lot of dimension to go to understand it. But if we're looking at this language as a way to create concurrent programs, you'll see that Go can also be used not only for what it is used usually. It hurts me a bit to see that now Go has a reputation of a language for microservices, for some CRUDs, for utilities, for DevOps, because in fact you can write anything on Go. I was passing skipping through some quotes saying Go is a concurrent language with a heap collection, garbage collection. with a thought about systems programming, system programming in mind. But in fact, Go includes systems programming as an application area. I think it's very important. And such tools as TinyGo that have been completely developed by the community. They've been fully built by developers. The support of WebAssembly. Go core team has no relations to its support. It was the community that did that. Just rank and file developers, just yourself and myself, they just came in and improved the tool and use WebAssembly, for instance. The capabilities are becoming infinite. You can now start it anywhere for anything, and I would like it to keep developing. This brings me to the end of my presentation. Thank you for listening. If you want, you can vote for my presentation. My contact details are here as well. I would also like to mention Maria Letta's project, Free Golfers Pack. I used illustrations from this project, and also she on my request, made some pictures, illustrations, for which I also thank her a lot. I have stickers here, and I'm handing them out absolutely for free. Please just come to me, and I'll be happy to give you one. Thank you.
Alexei, спасибо.
Alexei, thank you. I think after this presentation, it'll be easier for everyone to pass through an interview with you. I'll remind you that you can use this QR code to leave feedback. And now we're moving to Q&A, and we have a present for the best question. A question for myself. Do you still write on Go, or you can also play Go? Yes, I'm a bad Go player, but has anyone played in Tochka, in this Tochka school? Tochka is the same, the point. It's an absolutely the same game. That perhaps is all I can say about my skills. I'm curious. I would like to take more time doing that, but unfortunately I don't have it. Okay, thank you. Please use the microphones to ask your questions. Introduce yourself. Hello, Artyom, Positive. Thank you for your presentation. I am interested in the fact that a certain part of this presentation was not really devoted to the default compilation capabilities, but more on TinyGo capabilities. I am a little bit saddened by the current state of how it collects, because, for instance, Go builds on WASM work 4 or 8 times slower, and the TinyGo build will weigh 10 kilobytes, and the Go runtime and the Go compiler that will be carrying the entire runtime will be 2 megabytes large. The difference is the factor of 200. So it would be nice to see that they would improve this WASP build. Guys from Google have been talking about that. But if you start getting deeper, you see very unpleasant things emerging. Thank you. Well, I couldn't hear everything because there's an echo here. Let me just try and repeat what you say. So you're saying that you use TinyGo, and TinyGo was a lot different compared to the official Go. Yes, the official Go WASM support loses a lot compared to TinyGo. Is it possible that it will be improved sometime? Because quite often in presentations, in recent presentations, I could hear that. But when you start seeing what's happening, you start seeing problems. Is the problem only in size or in speed as well? The problem is inside. But also the speed is, there's a big loss in speed. Yeah. And there are certain subtleties regarding the operation with WASM, for instance, WAS0.
Ну, смотрите, по размеру
Look, in terms of size,
такая возможность
TinyGo
полностью планировщика. Это
has this capability that you can take the scheduler out that will make it smaller.
сильно
You also have to bear in mind that the TinyGo scheduler is much simpler.
его убрать, да?
Yeah, you can choose the scanner or you can remove, but you get rid of the Go routine, and the mechanism of work is a bit more primitive. So if you need high load and high speed, I can't judge about your case because one needs to have tests, one needs to verify. But on the whole, my personal knowledge is that I haven't heard about any serious problems with performance of binaries compiled by the regular Go compiler. So look, maybe you've run into some specific situation. Maybe you have high concurrency, but the current implementation of WebAssembly is single-threaded. So maybe you're just having problems that your multi-threaded logic gets packed into a single thread, and this leads to this kind of problems. At the same time, TinyGo allows you to remove this whole story at all and work without it. As to the size, well, frankly, I wouldn't be worried about that because I've heard a lot these things, especially in the browser context. I saw people giving up on the project they would compile in Go, having 15 gigabytes, and were saying, how will I add it as a static to the browser? Simple, you just add and it works. 15 megabytes, not gigabytes, can be cached, and nobody of your users will even notice that. If you take a look at some popular website and take a look at the size of static information, they deal with much larger things than 15 megabytes. Talk about the browser, talk about the backend. I don't know, is it critical? How many such modules? For instance, in game development, it is becoming really critical. I saw cases where people would give up projects like that because of the big size. You can add compression, reduce by the factor of 8, but it doesn't fix the bad situation with the official WASM support. And why don't you like TinyGo then? Speed? A restricted start library, because this write time is needed. I suggest that after the presentation you come to me and we have a discussion. Okay? Okay. Hey guys, any more questions? Yeah, let's change because the Q&A time is limited.
Меня зовут Тимур из F6.
My name is Timur from F6.
Здесь тоже беседовали.
We already had a discussion in the previous PhD. My questions would be tricky ones, I guess, because this with system programming, myself being a systems programmer, I can ask you two questions. Firstly, so it appears that if inside of Go, EPOL for net polling works, then you can't run Go on Linux earlier than 2.15, right? Right. And second,
Я для себя думаю, вот почему
I am thinking for myself, why Go is not a fit as a system language? It's a lack of memory control. I don't know ways, maybe you'll suggest me how to control memory allocation. Because when I was writing Go, I encountered a problem more than once that an immediate growth in load makes Go allocate memory which I can't free up, even though I no longer need it. It could be showed by some allocator pre-allocating the pool, but you can't do that in Go. Or you can. So my question is, are there ways in Go to control memory? Are there ways in Go to redefine pooling mechanisms? Are there any ways to redefine the behavior of the language? Because it's not specified, as I heard from your presentation. In terms of language, no, except for unsafe. So if you approach it formally, in the Go specification, it's the only standard library, unsafe, that's mentioned. In unsafe, there's a mechanism described in specifications. Of course, you can do some magic based on pointers and things like that, but the specifications say that Go is a garbage collector-based language. So the answer is rather no than yes. Of course, you can bypass that. There are interesting ways, and you can write a program without allocation. It's all in the stack. Zero allocation. There are libraries that it's just like an advertising, a slogan, zero work. Well, still, it's just a stack allocation, right? So, hey, guys, if you could continue that one-on-one, but we're very limited in time. There are other hands being risen. Hello, Ilya. I have two simple questions. Closer to the microphone, please. One is about the following. Have you ever encountered the closed code? I personally haven't, but there are projects that allow you to entangle it a little bit. Yeah, I would like to learn more, maybe later. And the second question about decompiling Go applications, also about mechanisms and protection against them. There are special projects that allow you to hide this logic, but one needs to take a close look at the project specifically. I haven't used this in my practice, but there are cases like that. You can do decompilation, you can do reverse. Well, reverse is comprehensive. You can decompile everything, and Go programs are not an exception. So that depends on a specific problem. I will hardly be able to offer you a solution how to hide logic from reverse engineering. I personally believe that it's not possible in principle, but projects are like that exist. So, any more questions? Thank you for your presentation. My name is Alisher. My question is quite simple. I'm a .NET person, and I tried Go recently. On the whole, I liked it, but the one thing that I was surprised was where to find an agreement on code commenting. Do they exist? For documentation writing, to comment code in Go. Like in .NET, we have comments. Yes, I was just looking for them. Go.comments, there's an official site. There's a special article, Go.comments. Thank you very much. So, if there are other questions, I think we'll be able to take the time. Another small question. Does the Go have a future on the WebAssembly application? You mentioned OGS and the billing. On Go, there's an alternative of the SPA app framework called Go app, and a lot of large companies and startups they have migrated all their front end to Go. That's it. It's MaxChair, and that library is called Go app. Go app. It builds to the DOM over Syscall.js and also builds it on WASM. Do you remember the author? I'll tell you later. I think I know what you're talking about. Yes, indeed. There are solutions like that. And frankly, if I understand the library correctly, I may be confused a bit. I looked at it and I didn't quite like it because you need to take to write the HTML code as Go code. I don't believe this is a convenient approach. For me, it works better to separate the HTML and Go code. They're using this approach with service workers. That, for me, is not very comfortable. But in principle, it's one of the good projects that have been worked through very well. It's been in existence for quite a long time. It supports WebAssembly. I personally am not aware of many projects that would use WebAssembly as the foundation, as a basis. And all the projects that's brought into the community, they are more decorative, more like proof of concepts, things like that. But nevertheless, they do exist. In the WebAssembly community, there are quite a lot of these projects. For instance, there are projects that allow loading a module, and all sorts of primitives are used. It's all output in an elegant way, and it's all done in WebAssembly. I've encountered things like that. I have my projects as well. But otherwise, there are not too many. The technology is still being developed. I think that would be my answer to your question. Thank you. Thank you. Thank you all for the questions. And I would ask all of you who have asked questions to stand up. It will be easier for you to remember them. So I've already delegated a gift to you last year, so perhaps I'll award it to the first commenter. He had a lot of questions. For the first question and last one, I would award for both. And let me remind you that those who are interested, please come to me and get the sticker.